Session 2.2, 2.3, Histogram and Graph. I will combine Session 2.2 and 2.3 together. Last session, we used frequency distribution to organize and summarize data. These two sessions, we will learn how to use different graphs as a tool to interpret the data. The first one is histogram. Histogram is a graph consisting of bars. The y-axis are usually labeled with frequency or the relative frequency. The x-axis are usually labeled with cast boundaries or cast midpoints or lower cast limit. For an example, we have the data of statistic exam grade and we want to construct a histogram. And in this example, we already found out what is our lower cast limit. And we will use the lower cast limit as my x-axis and the frequency as my y-axis. So this is the histogram. And let's try another one. This time, we will use the midpoint as my x-axis and the relative frequency as my y-axis. So I will got the histogram look like this. You should see that both examples have the same shape, even though I use the frequency or relative frequency. And histogram are not very helpful with the small data set. So if you have the small data set, you better use other graph to represent your data. Okay, after we know how to construct a histogram using the frequency distribution, we want to know what is the advantage or disadvantage using the histogram. Like this example, instead of looking all the individual data, we could see the patterns from the histogram. And this is the histogram showing the statistic exam grade. We can easily find it out. We have 6 students getting the grade about from 80 to 89. And we have 4 students getting A. Okay, 4 students getting A, 4 students getting C, and we have 6 students do not pass this class. And that will be the advantage for using the frequency histogram. And one more thing, we could determine the sample size from the histogram. When I look at the histogram, I could tell how many students' grades are here. Okay, so this is going to be the advantage. And disadvantage, individual data values are lost. We can't tell what exact grades do the students get. I only know like there are 6 students getting from 80 to 89, but we don't know about like what exact grades do they get in this exam. Okay, if we're using the relative frequency on histogram, we could easily to find out the percentage of data. For example, we could say that is 30% of the students who get about like 84.5. And we have a 20% of the student getting A, 20% of students getting C. And this is really good for presentation if you want to present it with the percentage. And for the disadvantage, the number of the data values in each group is lost. Okay, we can't find out what is exact data that we get it in each point here. For the disadvantage, the number of the data values in each group is lost. So similar to the previous one, we can't find what exact grades do the students get. And one more thing, from this picture, can you guys find out what is the sample size? How many students are there? No, right? Because we're using the relative frequency. We only can tell the percentage of the students, but we can't tell how many students are there. So this is also like the disadvantage for using the relative frequency histogram. The histograms have four common distribution shapes. The first one is a normal distribution. It looks like a bell shape. Remember, the normal distribution means the frequency start low and then it increases until reach the maximum, and then you're gonna go back to low again. It's about the symmetric. And second one is a uniform distribution. That means the frequency is about the same here. The third one is the skew to the right. Skew to the right means that the distribution appears has a left leaning curve, or you could think the right tail is longer. The fourth one is a skew to the left. Same idea is that the distribution appears has a right leaning curve and or the left tail is longer. Okay, number 2, scatter plot. A graph of plot points that show the relationship between two sets of data. For example, a real estate agent wants to study the relationship between the size of a house and its selling price. I have the data about the size and the selling price of the house. To construct a scatter plot, I use the size of the house as an x-axis and the selling price of the house as a y-axis. So for the first data, the house is 2,521 square feet and it sells 400,000. So this is how I get the first dot here. And this is the second data. I have a 2,555 square feet and then it sells 426,000. So now I obtain the scatter plot with size and selling price of a house. Okay, how do I know if there is a relationship between these two variables? We could draw a straight line here. If most of the points are along the straight line, then that is a relationship. Or we can say that is correlation, means that the two variables has a relationship. So in this example, all the points are along a straight line here. So it is reasonable to suspect that the selling price is related to the size of the house. Okay, let's look at other example. I have a scatter plot of the weight and the pulse weight. Okay, is there a linear correlation between the weight and the pulse weight? No, right? Because it does not show any obvious pattern. So that's a no correlation. Or you could say I can't draw a straight line here and all those points around the straight line. So that's a no correlation. Okay, number 3, time series plot. A graph of time series data, which are quantitative data that have been collected at different points in the time, such as monthly or yearly. Remember what is a quantitative data? The data that consists of numbers. So we use the time as the x-axis and the value of the variable as my y-axis. So we have an example of Dow Jones of industry average. So year has my x-axis and the average has my y-axis. And then we will use a dot to represent each data. And then we're gonna draw all those points with a straight line here. So this is my time series plot. Okay, dot plots. A graph that can be used to give rough impression of the shape of a data. It is useful when the data is not too large and when there are some repeated values. For example, numbers of children of United States presidents and their wife. So I use the data to construct the dot plots here. So here, the two dots above the position at 1 indicate that two precedents had 1 children. And then for example, like here, the 3 dots above the position at 5 indicate that 3 precedents had 5 children. So each data value is represented by a single point. Okay, now try to do the question 1 and 2. So first one, how many presidents had more than 6 children? More than 6, okay? So this is a 6 here, more than 6. So I have 1, 2, 3, 4. So we have 4 presidents had more than 6 children. And then number 2, what is the most frequent number of children? So within this graph, we can see that the most number of dots above the position is at 2 here. So 2 are the most of number of children. Okay, stem plots, or you can call stem and leaf plot. It represents the data of each value into 2 parts, the stem and the leaf. For example, we have a data of scores on a final exam. For the first data, we have 58. So the 5 is the stem, and then the 8 is the leaf here. Okay, so this is the stem plot. We have the first one, 58 here. And then the second data, the leftmost digit is the stem, and then the rightmost digit is the leaf. So you can see 66 here. And then third data is 68. So 6 is my stem, and then the 8 is my leaf. So 68 here. And here, you can see there are 2 zeros next to the 7. So there are 2 data of 70. So 2 data of 70. And there are 2 ones here. So there are 2 data of 71. Okay, when you construct the stem plots, make sure you arrange the data in order. Okay, so that you can see the stem here, the data is in order. And for the leaf, the data is in order also. Okay, let's try another example on weight of college students. And you can see this example has 3 digits of each data. So which digit is the stem and which digit is the leaf? Like for the first data, 136. So we will use the 2 leftmost digit has the stem, and then the rightmost digit has the leaf here. Okay? And make sure you arrange all the data in order. Okay, I give you guys some time to try this example. Okay, please check your work. Okay, make sure you put it in order here and put it in order. Okay, number 6, bar graph. A bar graph consists of rectangles of equal width with one rectangle for each category. So look at this example. The frequency distribution for computer cells. Okay, I want you guys use the data to construct a bar graph. Use the type of computer here has x-axis, and use the frequency as the y-axis. Okay, check your work. So this is the bar graph here. Okay, I have a question. This graph looks like a histogram too. What is the difference between the bar graph and histogram? Some students may say there's no gap in between each rectangle for the histogram, right? But no, this is not true. I can have a gap in between each rectangle in histogram also. Okay, so the difference between the bar graph and histogram. You will use the bar graph when you have a qualitative variable. Remember what is a qualitative variable? Consists of names and labels, just like this example. Okay, I have a qualitative variable. This is a names and labels, right? So we use the bar graph. And you will use the histogram when you have a quantitative variable. So quantitative variable means represent the kinds or measurement. Means like you're using the number, then you're going to use the histogram. Okay, number 7, parental charts. A bar graph in which the characteristics are presented in order of frequency or relative frequency, with the largest frequency or relative frequency on the left and the smallest one on the right. So this graph is similar to the bar graph, but we arrange in descending order according to the frequency. Okay, in this example, we will use the relative frequency as my y-axis. Okay, and then the types of computer has my x-axis. So first, I want you guys try to calculate the relative frequency. I will show you guys how to do the first one. You're gonna add up the frequency here. The total is 50. And then the first one, I will use the 11 divided by 50, and which is equal to 0.22. So please complete the table here. Okay, check your work. Okay, after we complete this table, we will try to construct a parental charts here. So, which types of computer has the highest relative frequency? Okay, which one has the highest relative frequency? So here you could see the laptop has the highest frequency. So we will put the laptop on the left here. And then the next one, that will be the desktop, because the desktop is 0.22. And then that will be the notebook, and then the last one on the right hand side should be your tablet. Okay, so the parental charts is according to the frequency. The highest, the largest frequency on the left, the smallest frequency on the right here. Okay, number 8, the pie charts. Pie charts is a graph that depicts qualitative data, has a slice of a circle, in which the size of each slice is proportional to the frequency count for the characteristic. So we need to calculate the size of the sector. And then this is going to be the formula. It will be equal to the relative frequency times the 360 degree. Okay, we will use the same example, the types of the computer here. And we already find the relative frequency. And now I need to find the size of the sector. So I'm going to apply this formula. Relative frequency 0.22 times 360 degree. And you should find like 79.2. But we will want it to the nearest degree here. So can you guys complete like this table? Okay, try to round it to the nearest degree. Okay, check your work. And when you add up the size of the sector, it should be equal to the 360 degree. Okay, because the measurement of the circle, it should be 360. Now we use the data to construct the pie charts here. Okay, you may need to use the protractor to construct a pie chart, or you could just like do the estimate. Like the first one, 79 degree. That means this slice of the circle is going to be 79 degrees and it will represent the desktop here. I use like 22%, okay? So this is a percentage frequency. You just need to times 100% from the relative frequency here. So you can see 22% for the desktop. And then the second one here, 50 degrees. So this part is going to be 50 degrees. And this is belong to the tablet. Okay, so times 100% here, that will become 14%. Okay, so again, when you add it up here, it should be 360 degree. And when you add up like this percentage, it should be equal to 100%. Okay, frequency polygon. Use the line segments connect to the points located directly above cast midpoint values. And a frequency polygon is very similar to the histogram, but a frequency polygon uses the line segments instead of the bars. Okay, let's try an example using the statistic grid. And do you guys remember how to find the midpoints? You're gonna add it up here and then divide it by 2, right? So can you guys complete this table? Okay, check your work here. Okay, now let's try to construct the frequency polygon. We'll be using the frequency has the y-axis. Okay, this is gonna be my y-axis, and then the midpoint, that will be my x-axis. And before we start working on it, we need to find a midpoint before the first cast interval. So this is the first cast interval. We need to find the midpoint like before this guy. So that will be 34.5. And also, we need to make up one more midpoint for the last one. Okay, the last cast interval, we need to make up one more midpoint from here. Okay, that will be 104.5. And since we make up these two midpoints, so the frequency, that will be equal to 0. Okay, make sure when you guys want to construct a frequency polygon, make up the midpoints from the previous one and also the last one here. And again, since we make up the midpoints, frequency will be equal to 0. Now, you can construct the frequency polygon, including these two midpoints. Okay, let's check your work. So the 34.5 will make it up and 104.5 will make it up also. Okay, and then the frequency is gonna be the 0 in here. Okay, we have to make up the midpoints for the frequency polygon because we don't want our graph is not touching our x-axis. We want like starting with the 0 here, starting with the 0, touching the x-axis. So that's why we make it up. And make sure your graph, you do have the title for it, and then you have label your x-axis and label your y-axis in here. Okay, the last one. O-drive is a graph depicts cumulative frequency. O-drives are useful for determining the number of values below some particular value. First, please find out the cumulative frequency. Okay, remember how to find the cumulative frequency? You just need to add the previous frequency. Okay, you should have this like this. Okay, one more time. I have a 1 here. 1 plus 2, you got the 3. 3 plus 3, you got the 6. 6 plus 4, you got the 10. 10 plus 6, you got the 16. 16 plus 4, you got the 20. Okay, now let's try to construct the ogive. We'll be using the cumulative frequency as the y-axis. So this is going to be your y-axis, and the midpoint, that will be the x-axis. And similar to the frequency polygon, we need to make one midpoint before the first cast interval. Okay, so before this guy, that'll be 34.5 again. And since we make it up this guy, so the frequency will be equal to 0. Okay, now you can construct the ogive graph. Okay, this one we only need to make up the first one because we want the graph is touching on the x-axis starting from the 0. Okay, we don't need to make up the last one because this is a cumulative. Okay, graph that deceive. Some graph deceive because they are technically correct but misleading. Here we present two of the ways in which graphs are commonly used to deceive. Look at this example. We have the highway fuel consumptions with 3 different brands of car. We have a Honda Civic here, Chevrolet, and also the Camry. And by looking this graph, you could say Honda Civic, they make a really good job here. That's a big difference compared with the Toyota Camry. Okay, but actually, if you pay attention on your vertical axis here, the vertical scale starting at 30 miles per gallon instead of 0 mile per gallon. Okay, if the vertical scale starts at 0 miles per gallon, the difference among the 3 mileage weighting and actually small. Okay, we try to do it again. See, we started from the 0 right now, and then now you look at the graph, the Honda Civic and then the Toyota Camry, it's just a little difference, right, compared with this guy. So the first graph here, we call this as a misleading, okay, because the vertical axis begin at some value other than the 0. Okay, graphs tend to be misleading when I'm not draw scale on the vertical or and the horizontal axis. Okay, this is talking about this is not the scale and makes looks like the graph is gonna be different. And then start with the 0 on the horizontal axis here. So you could I just mentioned if the vertical axis begin at some value other than 0, that's called misleading. But that will be different story for the horizontal axis. Okay, we don't want to start with the 0 on the horizontal axis. If you look at the example we did on the frequency polygon, see the horizontal axis here, we didn't start with the 0. Okay, even the ogive here, we didn't start with the 0 also. So we say graph tends to be misleading when start with the 0 on the horizontal axis. Okay, pictograph. Drawing of objects are often misleading. Look at this example here. If you didn't count how many bananas or apples are here, okay, if you just look at the picture, you may think we collect more bananas than the apples and the cherries. Okay, because the picture of the bananas are larger than the apples and cherry, so we say this is a misleading graph. If we graph it, they do have the same size of the picture. You could see we have the same number of the bananas and apples and the cherries in here. Okay, so sometimes pictographs are often misleading.